it out by talking about those transformations. We're going to combine those two concepts with some problems. So, nine to the, and there's a lot of different ways we could write 9 to the 2x. I could write it as, I could change that 9 to be a 3 squared. There's a lot of things that you could do. When you have a multiple choice question, you kind of just have to look at your choices to see what it's going for. You might try something, and when you rewrite it and you use these exponent rules, you might be right, but you still might not see that on your answer options. They could be trying to do something else. So what might come to mind when you see 9 to the 2x power? Okay, well, how did you get that?
9 to the square is 81. You got the x left over.
So when you have an exponent of 2x, that is the same thing as writing 9 squared to the x power. It's also the same thing as writing 9 to the x power squared. Those are, all three of these are the same thing. Using exponent rules, when you have an exponent to an exponent, those get multiplied. Well, I know that 9 squared is what? 81. So 81 to the x. If this was a question on the ACT, it very well could be. You could use your calculator. You could plug in a random number for x up there in all of your answer choices and see which ones match. On the AP exam, this 100% would be a non-calculator question. So you would have to know how to rewrite that. They're checking to know your exponent rules. 9 squared is 81. Okay. Some other things, like when I first saw it, I was like, okay, I know that 9 is 3 squared to the 2x, and then I thought to do 3 to the 4x power. But that's not an option. So this is not wrong. It's still correct, but it's just not one of the options they gave me. Okay. So we have the number 7. We have 9 times 4 to the x. Okay. Looking at my answer choices, I see a lot of these 16s. How do I get a 4 to have a base of 16? 4 is the same thing as 16 to what power? The 1/2 power, right? When you have a 1/2 power, that's the same thing as taking the square root. A 1/3 power is the same as taking a cubed root. So if you have to recognize these things. There's no formula. You have to just think, what do I know about 4? What do I know about 16? So 4 and 16 to the 1/2, those are the same thing. If I put in 16 to the 0.5 power, it's 4. That was the little fraction exponent rule we talked about. So I can change this to 9 times 16 to the 1/2 power to the x. So I replace that 4 with a 16 to the 1/2. Okay. And exponent to exponent, those multiply. 9 times 16 to the 1/2 x. I still don't see that exact option on there. But what is 1/2 x the same as? Like if I look at these. Yeah, x over 2. 1/2 times x is the same as x divided by 2. 1/2 times 10 is the same as 10 divided by 2. So those are just two different ways to write it. So 9 times 16 to the x over 2 is C. number 8. Describe the transformations required to take f of x to g of x. Here's f of x. G of x is f of x times 125. So I'm going from 5 to the x to 5 to the x times 125. Basically, with these types of questions, our goal is to get them like combined into one the best that I can and get all of them to have the same bases if I can. So 125, is there another way you could possibly write that has a base of 5? Five cubed.
Yeah.
5 cubed is 5. 5 times 5 times 5 is 125. So I can rewrite that as 5 to the x times 5 cubed. Since these are both 5 to some power, what do I do with these exponents? You add them. When you're multiplying 5 to the x, 5 cubed, you add the exponents. So 5 to the x plus 3. So if I started at 5 to the x and I go to 5 to the x plus 3, what transformation is that? Horizontal. What? X plus 3. Translation of how many units? Negative 3 units. So x plus 3. The plus 3 is right with the x. X plus 3. That's a horizontal translation. Anything with your x's is opposite. It says plus 3, but it's actually going left 3. It's actually minus 3. And again, I told you yesterday, I started out by teaching you left 3. That's what I do in Algebra 2. AP Pre-Cal is not going to use that vocabulary. They're going to say horizontal translation of negative 3 units. That's why I'm changing that now. Okay. Number 9. We're starting at 7x. And we're ending up at 49 to the x. You can't compare or figure out what transformations happened unless they have the same base. So I need a base of 7. What can I do to this 49? How can I rewrite it to have a 7? 7 squared. So this is the same thing. 49 is the same thing as 7 squared and then to the x power. And how can I rewrite this? When you have exponent to exponent, you multiply them. So this is 7 to the 2x power. If it was 7 squared times 7 to the x, then it would be x plus 2. But it's 7 squared to the x power. So here we have a number being multiplied right to the x. That's going to be a dilation. It's going to be a horizontal dilation because it's to the x. It's not x plus 2, it's x. This is x times 2. That's a dilation, horizontal dilation. And what is the scale factor? Remember, x's are opposites. So it's not going to be 2, it's going to be 1 over 2, 1/2. So the scale factor is 1/2. So I would multiply any x value that I started with by 1/2. I have f of x is 4 to the x, and then I'm doing negative 4 times f of x. So that is negative 4 times 4 to the x. And technically we could call this one, we have the negative. We know the negative is going to be a reflection. Negatives are always reflections. And the 4 being multiplied in front, and that needs to be up here, doesn't it? That could be a vertical dilation. So we could put that, but that's not requiring us to change anything. So how could I write a 4 with an exponent that still has a base of 4? 4 to what power is 4? 1. This is the same thing as negative 4 to the first times 4 to the x. Again, sometimes you just have to play around. What do I know about these numbers? This would probably fall in your multiple choice. So if you did not see a vertical dilation of 4, then you know you probably need to work around with the numbers some more. So if I have 4 to the first times 4 to the x, this right here is the same thing as 4 to the x plus 1. If you type this into your calculator, putting some random number there, and you type this in with that same x value, they should be the same thing. Those are equivalent, just different ways of writing them. And now I can see this one has 2 transformations. It still has the negative. That negative didn't go anywhere. So that is reflect across. Which one has the negative in front? X-axis. And the plus 1 is with the x. Adding or subtracting is a translation. So it's a horizontal translation of how many units?
4.
Negative 1. You're good. So it's adding 1 in the exponent. The translation is actually negative 1. So we're going from 16 to the x to 2 to the x. So I have to, this is my starting one. I have to see what I do to the 16 to get here. So we want to rewrite the 2. G of x is the one we're always messing with. Okay, so 2, I've got to write that to change it to have a base of 16. 16 to what power is 2? 16, let's see. 16 to the 1/8 power is not 2. To the 4th is 2. Because 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th is 16, which means that 16 to the 1/4 is 2. They kind of go hand in hand. So I'm going to write this as 16 to the 1/4. 16 to the 1/4 to the x is the same thing as writing 2 to the x. And this is really 16 to the 1/4 x power. So now I started here, 16 to the x, I ended here. We can compare those now because they have the same base. You can't compare them and say these transformations happened unless they have the same base. The only thing that changed is now there's a 1/4 in the exponent with the x. So what type of transformation is that? Horizontal dilation. And what's my scale factor? 4. Okay, horizontal dilation, scale factor is 4. Okay. Number 12. Starting at 2 to the x, and then I'm ending up with that same 2 to the x over 32. This one's weird. 2 to the x divided by 32. Well, my guess is I can probably do 2 to the some power. I can change this 32. So let's see. 2 times 2 is 4, times 2 is 8, 16, 32. So 2 to the 5th. So that's the same as writing 2 to the 5th. Two to the x. Yep. So 2 to the x over 2 to the 5th. I don't like that being in the denominator. We didn't talk about any transformations and having a fraction, like no denominators. We haven't talked about that. So I could make this 2 to the x times, does anybody know 2 to the, this is one of our exponent rules. I remember, -5. When you had a negative exponent, remember we sent it to the bottom. Now we're just going back. We're taking it from the bottom. Bring it back. Which is 2 to the x minus 5. And so this would be a horizontal translation of 5 units. So you had to get it to one base of 2 to see what happened. There's no way you would have got that just by looking at over 32. All right, and last one we're going to do real quick. We have 6 to the x, and we're going to that to the -4th. 6 to the x to the -4. That's the same thing. This one's easier. It's 6 to the -4x. Two things are happening here. Write down what those two things are that you think. You've got the negative and you've got the 4. It's a reflection across the y-axis, the negative. The negative being up there with the x is y-axis. And then the 4 up there, horizontal dilation, scale factor 1/4.